Algebra 2, Unit 4, Day 1 notes. We're going to look at graphing linear inequalities as opposed to graphing linear equations. So starts right off saying that there are two new parts to think about because these are inequalities. Okay, inequalities means that we're using these inequality symbols, either greater than, less than, greater than or equal to, or less than or equal to, instead of the equal sign. Okay, so first thing is line type. If you have a greater than or equal to, or a less than or equal to, you're going to have a solid line, just like you had a closed circle before on the number line. Okay, if it can be equal to, we're going solid line. Now, if it's not equal to, if it's less than or greater than, it's a dashed line. Okay, pretty simple stuff here. Now, you're going to be shading. Okay, you're going to be shading. Okay, so you're going to shade above or to the right. Okay, above the y-intercept to the right of the x-intercept. Okay, if we are talking about a greater than or a greater than or equal to. Okay, so if it's greater than, it'll be a dashed line and above or to the right. Okay, if it's less than or equal to, we will be shading below or to the left. Okay? So below the y-intercept to the left of the x-intercept, right? And hopefully it'll be clearer after we do a couple of these questions. We'll start with vertical horizontal lines, okay? Now, y is less than 3. We're going to graph this inequality. And again, we go back to Hoy-Vux, right? When we're talking about horizontal lines that have zero slope, the equation was y equals, or in this case, y is greater than or less than. So I have 2 steps for you. Well, actually 3 steps. Step number 1 is graph the boundary line. Treat it just like it said equals instead of the greater than or less than, and graph it. But step 2, make sure that you know if it's dashed or solid. Okay, we already went over line type. Okay, so we're going to graph the boundary line and making sure that we know it's dashed or solid. And then finally, we're going to shade. If it's greater than, we're going to go above or to the right. If it's less than, we're going to go below or to the left. So let's look at this. So y is less than 3. So I'm going to pretend it says y equals 3. Y equals 3 is a horizontal line. I'm going to go to the y-axis. Here's the y-axis. I'm going to put a dot on 3, okay, because it says the y is going to be 3. And I know that this is going to be a horizontal line. Now my question is to you, okay, is it going to be dashed or solid? Well, this says less than. It does not say less than or equal to. So when I graph this, it's going to be dashed. Okay, because it's not equal to, it's just less than. And then finally, where do we shade? Okay, because this is less than, we will shade, in this case, below. Okay, we're going to shade below that y-intercept. So there's the y-intercept at 3. We're going to shade below. That's it. Okay, hopefully you thought that was pretty simple. Let's look at the next one. X is greater than or equal to 3. So again, we're going to graph the boundary line and think, are we going to go dashed or solid? Okay, so the boundary line is x equals 3. X equals 3, as we remember Hoy bucks. Vertical line, undefined slope, X equals a number. So we go to the X-axis. We look at the 3. We put a dot there. Okay, now, is this going to be dashed or solid? Well, it says greater than or equal to. Greater than or equal to. So it's going to be solid line. Okay, so I start at the 3, and I'm going to do a solid boundary line going up, going down. Okay, starting right at the 3. Last thing is the shading. Now it says greater than or equal to. So greater than or equal to, we're going to shade to the right or above. Well, there is no above because there's no y-intercept. Okay? So we're going to shade to the right of the x-intercept. So we shade to the right. Okay, that's it for that one. Okay, let's continue on. So that was graphing an inequality if our boundary line was vertical or horizontal. But now what if it's slanted? Okay, these rules are still good when it's slanted. Okay, notice that it says above or to the right. Okay, that, you know, if we were slanted and I said greater than, it would be above. Okay, if it were less than, it would be below. Okay. All right, so let's take a look. We're going to do the same 3 steps as I said last time. I'm going to graph the boundary line. Is it dashed or solid? And then we shade it. Okay, so this time the boundary line, again, we're going to pretend that this is like an equal sign. The boundary line is the line y equals 1/2 x minus 3. That is our boundary line. Okay, I want to know, is that going to be dashed or solid? That is greater than. Okay, it is greater than. It is not greater than or equal to, so it's going to be a dashed line. So I'm going to graph this, and I'm going to put a dashed line through it. How do we graph a line? Well, we start, especially if it's mx plus b form, I'm going to start at the -3. That's the b, that's the y-intercept. Now I'm going to rise 1 and run 2. Okay, so I start at that y-intercept of -3. I rise 1, run 2. Rise 1, run 2. Rise 1, run 2. I'll keep going. Okay, on Alex, all you need is a couple of dots. Okay. But again, this is a dashed line. And it's dashed because it's greater than, but it's not greater than or equal to. Okay. So now we have graphed the boundary line. This is the boundary line of y equals 1/2 x minus 3. We have dashed it because it was greater than. Now finally, we want to shade. Okay, it says greater than. Greater than will be above. Okay, it'll be above. So above this y-intercept, it's greater than. Okay. Good job. All right, let's do another one. Again, it's in the y equals mx plus b form. The m is -1, the b is +4. First step is to graph the line. And when I graph it, that right there tells me less than or equal to, it's going to be a solid line. It's not going to be dashed. So let's graph it. Okay, we're going to start with, let's go different color here. I'm going to start with my y-intercept, +4. So go to the y-axis, put a dot on +4. Okay, my slope is -1. So I'm going to rise -1 and run 1. That's going to put 1 dot right here. Rise -1, run 1, keep it going. Notice that my line is falling to the right because it's falling to the right, I know that it's a negative slope, which it's supposed to be. Okay, so I'm going to connect my dots. Okay, so we graphed the boundary line. We saw that it was solid. Finally, we want to shade less than or equal to. Less than or equal to is going to be below, okay? Below, under. So it's going to be under. Okay. If you want to check your shading, you can take any point where you have shaded that big interval. Like for example, 0, 0 is in that interval. So if I want to test whether my shading is in the right spot, it's in the right half, okay, I can take that 0, 0 and see if this is true. Okay? So let's put 0 in for y. Let's put 0 in for x. Okay, so 0 is less than or equal to negative 0 plus 4. So that comes out to 0 is less than or equal to 4. Is that true? It is. So because it's true, that point is a solution. That means that we shaded the right region. Okay? If you had found that that's not true, then that's a good indication that we probably should have shaded the other region. But it was true, we're in good shape. Okay, last thing for this set of notes. We're still going to do the same steps in graphing. It's just that at this time, we don't have y equals mx plus b. We've got the x and the y on one side and the constant on the other side. So we have to get the y all isolated by itself. Okay? And in order to isolate the y, we're first either going to add or subtract the x term, and then we'll divide by whatever is in front of the y, the coefficient. All right, so let's do that. We want y all by itself. So what are we going to do? Well, first thing we're going to do is we're going to cancel out the negative x. So I'm going to add a positive x. Okay, so that's the first thing I'm going to do. That cancels on this side, leaving me with positive 2y. So I've got 2y is greater than. Now I want to put my x first because I want it in mx plus b form. So I'm going to take that positive x, I'm going to put it here first. And that 4 was negative, so I'm going to make that a minus 4. Okay, and now my final step in my isolation of y is I'm going to divide, okay, divide by whatever the b term is, and that's the coefficient in front of your y. So what is the b term? It's a positive 2. So I'm going to divide, watch this, every term on both sides by my b term. So that cancels. It gives me y is greater than. Okay, I'm not turning the little symbol because I divided by a positive number. I've got x over 2 minus, and then 4 over 2, 4 divided by 2 is 2. Okay, now, a little word to the wise here. I want a fraction in front of my x. I don't want x in the fraction. So just remember that you can always do this. You can always call that you can always call it 1x. I'm going to put my 1 there and then my x right here. Okay, that gives me my slope of rise over run, 1 over 2, and I got my b, my y-intercept of negative 2. Okay, so now that we've done that work, now it's exactly like the questions that we just did up above. Okay, so let's go ahead and graph my boundary line. And this tells me that I'm going to graph it with a dashed line because there's no or equal to underneath my greater than. Okay, so let's graph a dashed line. Okay, here we go. -2 is my y-intercept. So let's go with green here. My y-intercept is -2. Rise of 1, run of 2. Okay, so rise 1, run 2. If I want to do another one, rise 1, run 2. Okay, rise 1, run 2 across the board. Okay, all you need to do is a couple of these on your Alex, and then it'll connect the dots for you. Okay. Now, we said this is a dashed line, so you're going to make sure it's dashed. There is a tool on Alex to make sure that it's a dashed line. And then the last thing you need to do is make sure that you shade correctly, right? So the shading, because it's greater than is above. So we're looking at this region right here. And if we want to test our answer, oh look, 0, 0 is in our region again. We could try 0, 0. If I put 0 here and 0 here, or we could go back to the very beginning, put 0 here and 0 here. -0 plus 2 times 0 is greater than -4. So that comes out to 0 is greater than -4. It's true. It means we did it correctly. All right, nice. Okay, let's do our last question for this set of notes. Again, we want to isolate our y so that we can graph this boundary line. So we're first going to subtract 3x, Okay, those cancel nicely. Okay, notice that I have -4y. I didn't cancel the minus, so I got to bring that -4y with me. Okay, all I did is subtract, so I'm not going to turn the symbol. -8 and then -3x. I want to put the x term first just because I really want mx plus b. So I'm going to put the -3x or -3x right here. And then there's a -8, so I'm going to put -8. Okay, that's probably one of the tougher steps to do right there, just keeping your signs in check. All right, next thing, we are going to divide by the b term. So we have to divide by -4. Divide by -4. My 8 went somewhere. We have to also divide the 8 by -4. Okay, so when we do that, these cancel nicely, and we get y. We get -3 over -4. The only thing I want you to think about in simplifying is the fact that negative divided by negative is positive. Keep your 3 over 4. I like 3 over 4. It's a simplified fraction. It lets you rise over run easily. -8 divided by -4 is +2. Now, the only thing I didn't put in was the symbol. We divided by a negative number. When we divide by a negative number, we have to switch the direction of our inequality. So this is going to become a greater than or equal to. That is a common mistake when people forget that. We divide or multiply by a negative, we swap sides of the inequality, okay? It used to be less than or equal to, now it's greater than or equal to. Okay, so now we can go ahead and we can graph our boundary line. Is our boundary line solid or dashed? Well, that little or equal to tells me it's a solid line. Okay, so let's go ahead with this. 3/4 x plus 2. We start with the b, which is +2. So we go up 2, oh, right there. Now, solid line, we're going to go rise 3, run 4. 1, 2, 3, 1, 2. So we start again at +2. 1, 2, 3, up, and 1, 2, 3, 4 to the right. Okay. Now, on your Alex, you can just connect the dots on that, and you're all done. And it's solid. Okay. Now, Last thing, it's an inequality. We got a shade. Greater than or equal to. Greater than, it's going to be up above. Greater than is going to be shaded above. So let's see if we can find a point that will work here. Okay, here's a point right here. 0, 3. 0, 3 is clearly in my interval. Okay? My interval that we shaded. So 0, 3. If I put 0 in for my x and 3 in for my y, let's see if it's true. 3 times 0, so 3 times x, minus 4 times 3, which is y, less than or equal to -8. Well, 3 times 0 is 0. 0 minus 12 is -12. Is -12 less than or equal to -8? It's true. So that means we shaded the correct region. Okay, that's it for day 1. See ya.